We want to find the equation of a line passing through the points 1, 3, 2, and the point -5, 0, 4. And so we can just sort of imagine these are points out here in space somewhere. So we'll imagine this is the point 1, 3, 2, and there's this other point here, -5, 0, 4, and we're imagining a line passing through those 2 points. So to write a vector equation or a parametric equation for this line, it can be helpful to think of what is the vector from the first point to the second point. The idea here is that we're going to parameterize this line by letting this be the point when t equals 0, and this be the point where t equals 1. The choice there is arbitrary. You could have gone the other direction as well. So to find this vector, we find the difference between the how much the x's, y's, and z's change from the first point to the second. So going from 1 to -5 is a decrease of 6 in the x direction. Going from 3 to 0 is a decrease of 3. Going from 2 to 4 is an increase of 2. And so the direction vector for the line is -6, 3, -3, 2. Now we can write the equation for our line. R of t is, so a position vector pointing to our starting point would be 1, 3, 2, and our direction vector here is -6, -3, 2, and there is a vector equation for this line. Now notice we also could have written this in parametric form by letting x of t be, well, we start at 1, and it decreases by 6 for each t. Right? This corresponds to the first component of our vector form, 1 and a -6t. For y, my y value starts at 3, and it decreases by 3 for each t, and z starts at 2, and increases by 2 for each t. Now again, remember parametric equations and vector equations are not unique, and so if we had started at this other point, the equation would be different, but it would be equivalent to the same line.